Math 1332, Chapter 7, Consumer Mathematics, Section 4, Compound Interest, Video 2, Compound Interest Formula. In the previous video, we transitioned from simple interest to compound interest by entertaining the notion of pausing an investment between the beginning and the end of the term and calculating the interest earned up to that point, adding it to the principal, and then reinvesting all of that amount for the next time period. The result was we got more money. And the more frequently we compounded interest, the more money we seemed to get, although it seemed to start tapering off. In this video, we're going to see what the formula is for calculating the future value when interest is compounded. When an investment involves compound interest, there are 4 values you need to know in order to calculate future value. 3 of them you already know. P equals principal, R equals interest rate, T equals term in years. These were the same parameters that we used when we calculated simple interest. But now we have a 4th variable. N is the number of times interest is compounded per year. Because unlike simple interest, we don't just wait till the end to calculate interest. For compound interest, we stop and calculate interest at regular time intervals, add that interest to the principal so that in the next time interval, our pile of money that's growing is bigger and therefore earns more interest next time. The value of N often comes from an adverb in the statement of the question. In case you've forgotten what an adverb is, it's a word that describes a verb, an adjective, or another adverb. You can spot a lot of them because they end in ly. For example, if interest is compounded annually, that's 1 time per year, so N equals 1. If interest is compounded semi-annually, that's 2 times per year, so N equals 2. If interest is compounded quarterly, that's every 3 months, so that's 4 times per year, N equals 4. If interest is compounded monthly, that's 12 times a year, so N equals 12. And when we get to weekly, that's a little bit spotty because 1 year is not exactly 52 weeks, but if it is compounded weekly, then we assume N equals 52. And then compounded daily would be N equals 365. I know in leap years, blah, 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 and we also discussed Banker's rule, but don't use the Banker's rule unless it says use the Banker's rule, which says N equals 360 when it says compounded daily. And by the way, these are not the only values of N there can be. We could compound interest twice a day. So we would double 365 to get 730, and N would be 730. We could compound interest once an hour. That'd be a lot of times per year. But these are the most common values of N because those are the most common adverbs following the verb compounded. All right, so let's take a look at we can't look at an example until we see the formula, which I already have written here. Here's your formula. If you invest a principal P at R% interest, compounded N times per year, that should say times, for T years. So there's all of our players, if you will. P is how much money you're investing, R is the interest rate, N is how many times per year interest is compounded, and T is the length of the term. Then the future value of the investment is A equals P times parentheses 1 plus R over N, all to the NT power. Now, most books, when they write this formula, they write it exactly like this. I'm going to write it with 1 additional set of parentheses around the multiplication problem in the exponent. And the reason for that is, depending upon your calculator, you may or may not need to put parentheses around that multiplication problem. But it's better to put the parentheses and not need them because it would still be correct than to not use them but need them, which would make it incorrect. Just a couple of comments about the pieces of this. The 1 represents 100% of your principal before you add the interest onto it. The R over N is how much interest you get each compounding period. For example, if you got interest 4 times a year, then you would take your interest rate divided by 4, and that smaller piece is the percent you would get each time interest is added. This N times T represents the number of times interest is compounded during the life of the investment. For example, if we did something monthly for 2 years, then we would do it 12 times 2 equals 24 times. So each piece of this formula has a meaning. Again, the 1 represents 100% of the principal before you add the interest on. The plus, of course, is adding the interest on. The R over N is the interest rate divided into smaller pieces since you're getting interest more frequently during the year. And the N times T is the number of times total that you would get interest over the life of the investment. We'll take a look at one example and go ahead and wrap up this video. This is actually part of the previous example from a previous video when we were looking at what would happen if we got interest more frequently by investing $1,000 at 4% for 2 years. Suppose you invest $1,000 at 4% compounded monthly. What is the future value after 2 years? Let's document everything that we're given. Our principal is $1,000. Our rate is 4%, so 0.04. Our term is 2 years. But the N is the number that you rarely see in the problem, but you have to extract it from a word because the N is the number of times per year. What's the one word in this problem that says the number of times per year interest is occurring, is compounding? The answer is monthly. If something occurs monthly, it occurs 12 times per year. We have all 4 values, so we can put them in our compound interest formula, which I will write here again. A equals P times 1 plus R over N to the N times T power. So in this case, our principal is 1,000. 1 plus, the interest rate is 4%. Because interest is compounded monthly, N equals 12. And then the exponent will be 12 times 2. Now, if you're the type of person that likes to do a little bit of a problem at a time and then write down the results, I would not do that. Because number one, you're going to be doing a division problem, which will often lead to repeating decimals, which forces you to round, which creates an inaccuracy in your answer. And number two, if you did round that off, then this would, the 1 plus that decimal would be an approximation, and multiplying it to a high power would increase the error in the final answer. So what is it I'm trying to say? Your best strategy for getting the answer to the homework once is to put all of this in your calculator at once. The only thing you have to know is that there's a multiplication there and where the exponent button is. 1,000 times, open parentheses, 1 plus 0.04 divided by 12, whatever the division button looks like on your calculator, close parentheses, exponent, which I will type this way because on a lot of calculators, the button that means exponent looks like that. On some calculators, it looks like this, or x to the y. But you need a calculator with an exponent button. You need to know where it is, and you need to know how to use it. The exponent in this one is a multiplication problem, and this is why I put parentheses around the multiplication problem, because without them, this exponent 12 would happen first, and this times 2 would happen at the end. The parentheses trump the order of operations and say all that belongs in the exponent. Now, the next video, I'm going to spend a little bit more time talking about using calculators, but for now, I'm just going to go ahead and type this in. 1,000 times, open parentheses, 1 plus 0.04 divided by 12, close parentheses, exponent button, where's mine? Open parentheses, 12 times 2, close parentheses, and then finally press equals. And the interest, well, we're still calculating the future value. And the future value to the nearest cent, well, this isn't right. I got $1,083,142.96, which I know isn't the right answer. You're not going to put $1,000 in a bank at this interest rate and get $1 million in 2 years, or everybody would do it. So I'm going to re-enter everything that I just said and try to figure out where I went wrong. I think I know. 1,000 times, open parentheses, 1 plus 0.04 divided by 12, close parentheses, exponent button, open parentheses, 12 times 2, close parentheses, equals. And our future value is $1,083.14. And if you go back and watch the video that listed different future values, this was the one when interest was compounded monthly. Speaking of interest, one important thing to point out about the compound interest formula is it is not a formula for interest. It is a formula for future value. If you want to know how much interest you earned, you have to remember that interest is the extra you get on top of your original investment. So in other words, if we want to calculate the interest here, we have to take the future value and subtract the principal. Our future value is $1,083.14 minus the principal that we invested was just $1,000. And if you subtract those, you get $83.14. So the compound interest formula actually doesn't calculate compound interest. It calculates the future value when interest is compounded. Subtract, and you can find the interest earned.